Hello, beautiful people, and welcome. In today's video, we are talking all things law of sines. So what's really special about law of sines is we are no longer using right triangles. Law of sines and law of cosines allows us to have these ratios for the angles and sides for triangles that are not right triangles, which is pretty cool. So let's go ahead and start with what law of sines kind of tells us. Law of sines tells us if you take the sine of angle A, let's call this angle A here, and put that over the side A, that's going to equal sine of angle B, let's call this angle B, and its ratio to the side B. And then angle C and side C also have a relationship with each other. So I know some of you are going to have a little bit of a difficult time naming these triangles. The way I like to think of law of sines is as long as you take a sine of an angle and put it over the opposite side, then you're good to go. Another way to name these sides, sometimes you're going to see instead of like C, you're going to see side AB. Instead of B, you're going to see a side AC. And this is not set in stone. So you can put A, B, C anywhere you want. Typically, C is your longest side or your largest angle here. But it doesn't have to be. You can put them wherever you want as long as you have that relationship. So let's go ahead and start out with example number 1 and show you how this will look like. Whenever you're giving angle, angle, side, or angle, side, angle, you use law of sines. I personally don't necessarily remember that. What I like to do is I like to see if I have angles and sides, angles and sides. So for example, I see an angle here and I have a side across from it. Then I know that I'm going to have sine of 52 over x. And that's going to equal, here's another angle, and here's the opposite side. So that means it's going to be sine of 50, just kidding, that's a 34 degrees, and that's going to be over 10. If you're able to make this ratio, if you're able to make this proportions, then you can use law of sines. If you do this and you have too many unknowns, then you can't do it. That's how I know how to do it. All right, so let's go ahead and solve this. You will need a calculator. This is one of those times where it's going to be approximate your answer. This is not exact trig ratios. This is where we're guesstimating using our calculator. So on our calculator, I'm typing in sine of 52. Actually, you know what? Before I do that, let's figure out what this is. So I'm going to say sine of 34 equals divided by 10. And that's going to give me a decimal, and that's okay. So I have sine of 52 over x is equal to 0.055919. And I'm too tired to write the rest, but in my calculator, I'm going to keep it. This value here, be careful because you have an x in your denominator. So what you could have done here is you could have flipped both fractions if you wish. I'm going to choose to do that now, or you can multiply by x both sides and then divide by your 0.055919-ish number. So I'm going to say sine of 52 divided by 0.055919290347. So my calculator tells me, and that tells me you have a value of approximately 14.1. Now, there are no units for the side measure, so we don't know if this is inches, feet, yards, miles. We just know that it's a unit, so we're just going to write units. So what is the length of x? The length of x is 14.1 units. Let's try another one. Again, I'm going to check if I can use law of sines. Obviously, we can because it's in this video. But the way I like to check is I take an angle and I go across the street. I take an angle and I go across the street. So note here, I have an angle, which is sine of 64 over what's across the street, 32. That's equal to sine of 45 over this right here. And I don't know what that is. Like, I don't know what that is, question mark. However, that's not what they're asking us. They're asking us for this x here. This is what we want to know. So what we can do, and what's pretty cool, is use prior knowledge. And the prior knowledge that we're going to be using is the sum of the angles in a triangle is 180 degrees. So what that means is if I take my 45, I add it to 64, and I add it to whatever this angle is, and that's going to equal to 180 degrees. So because I need an angle here in order to be able to use this x, I can use prior knowledge about angles in the sum of a triangle. So I'm going to say 180 minus 64 minus 45, and that's going to give me an angle measure of 71. And now I can say, here's my angle measure, which is sine of 71, and across the street from it is the x value. Now note here, we don't need this, so I'm going to omit that. I don't need that. So I'm going to rewrite this as sine of 64 over 32, and that's equal to sine of 71 over x. Again, x is in the denominator, so let's do the step that I didn't do in the previous example. I'm going to flip both fractions. So I have 32 over sine of 64 degrees. Make sure your calculator is in the correct mode. We are working with degrees, not radians, so your calculator has to be in degree mode. I'm going to evaluate this, and before that, I'm just going to continue solving. So when I do it on my calculator, I'm just going to type it in once. Bubbles match, so x is going to be equal to whatever this is. So on my calculator, I'm literally going to type in inside parentheses sine of 71 degrees, close the parentheses. I'm going to multiply that by parentheses 32 divided by sine of 64. Make sure you have enough parentheses. And that gives me a value of 33.66354. Again, just read the directions and how they want you to round. In this case, I didn't tell you how to round, so let's just round to 2 decimal places. So I have 33.66. Again, units, you can write U, you can write units as the word. We don't know what unit of measure they're using, so it's just units. All right, so that's an example of how you use law of sines when you have angle, angle, side, or you have angle, side, angle. Again, I usually just take my angle, go across the street, take my angle, go across the street. If you're missing an angle and you go across the street and that's what you need, but you have 2 others, then you can use the method of subtracting from 180 to find your third angle. Let's move on with one other type of angles or information that you're going to have when you're dealing with law of sines. You're going to find angles for something that they have for side-side angle. When you are given side-side angles, you actually have a possibility of having 1, 2, or no solutions. You're going to have to double check. It's kind of like when we had extraneous solutions, but in this case, they're called ambiguous cases. So an ambiguous case just basically means it doesn't fit into our range. It doesn't fit into the parameters of sine. So the sine's function's range, so when you're dealing with sine, the range is between -1 and 1. If you have like 2, too big, it's out of the range, it's ambiguous. If you have 8, out of the range. If you have -4, out of the range. So you need to have your angle measure between -1 and 1. You need to have, not angle measure, you need to have the ratio between -1 and 1. If the sine function is positive, the angle, so if the ratio is positive, the angle can be in quadrant 1 or in quadrant 2. So to find, so this is where you have possibly 1 or possibly 2 solutions. If you find an angle that is in quadrant 1 or in quadrant 2, you find the other angle by subtracting from 180 degrees. Another thing to recall, we kind of already went through this, the sum of an angle measure of a triangle is 180, so you take all 3 angles, of a triangle, doesn't matter what type of triangle, it will equal 180 degrees. And number 4, you have to just keep in mind that a triangle cannot have two obtuse angles. So an obtuse angle is an angle greater than 90 degrees. So if you have an obtuse angle, if the angle is greater than 90 degrees, then you're done. All right, that being said, let's go ahead and do example number 1. It's a lot of information to throw at you. Go back and read them if you need to. This one doesn't give us a triangle, so you're going to draw a random triangle. This random triangle is not a right triangle because it doesn't tell us anything about right triangles. So here's a random triangle. How are you going to label it? However you want. Usually side C is the largest side, but it's up to you. So here's A, here's B. Note that the angles are capital letters and the sides are lowercase. And also note that they don't do like C right here. They give you AB. So that's okay. But let's go ahead and label what we have. Angle A is 50 degrees. Side AB, so here's AB, is 4. So in this case, C is equal to 4, or AB, we can call it AB. BC, which is here, that's equal to 9. And we want to know what the angle is for angle C. So it's a little bit different, but we can do it. Let's play this out. This is where you check if you can use law of sines, or maybe perhaps you have to use law of cosines. Let's find this out. Take your angle, go across the street. So that means I have sine of 50 degrees over 9. Take your angle. Again, go with what you have and what you need. I have this side. That means my across the street angle is when I'm going to take my angle. So in this case, angle C. So sine of C, you can put X if you want. And across the street from this angle is the side length of 4. So this is where it's a little different from example 1 and 2 previously. We are no longer finding the side length, we are finding the angle measure. So this is your unknown. To find it, you're going to do the following. Get rid of your denominator, so I'm going to multiply by 4, both sides. So my bubbles cancel. I have 4 times sine of 50 degrees over 9. And that's equal to sine of C. Okay. This, again, gets a little fun. Make sure you have a calculator. So I have 4 times sine of 50 degrees divided by 9, and that gives me a decimal. That gives me 0.34046-ish. Here's sine of C. If you watched my previous videos, then you know that here, when we're trying to find the angle measure, you could call this theta if you wanted to. We're actually going to be using the inverse of the function. So I'm going to take the inverse of both sides. I'm going to take the inverse of here. So I'm going to say sine inverse, right? Inverse of sine of 0.34046. That's going to be equal to my measure of C. So in my calculator, I'm going to be pressing second and sine for this inverse of sine. I'm going to type in my angle, or excuse me, type in my ratio, which is 0.34046. And again, use the calculator to get as precise as you can. And that's going to give me 19.905-ish. And again, read the directions to see what it's asking you to abbreviate to round to. And what is C? C is an angle measure, so you have to let the reader know that this is in degrees. So let's check if we have one angle, or we have two angles, or we have no angles. This angle right here, so far we're good. This is when we're talking about the range is between 1 and -1. If this value right here, this is the one that needs to be between 1 and -1. So if this value is not between 1 and -1, then it won't work. This right here, at this step, this is where you need to check. So if your value is not between 1 and -1, then therefore you have no solution. If you have this answer as a positive angle, which you're supposed to, positive angle, you're going to check for more by subtracting from 180. And again, you can abbreviate to 19.9 if you wish. So 180 minus 19.905, and that's going to be 160.095. So now we have two possible answers. We just need to make sure if it works or if it doesn't work. So we know that the sum of the angle measures of a triangle is 180 degrees, meaning if we add all of these angles together, it needs to equal 180 degrees. So if we are saying this angle C could potentially be 19.9 or it could potentially be 160. So to check your answer, take the original value that you have and you're going to add them and see if it leaves room for a third angle. So if I have 160, let's round, 160 plus 50, 160 plus 50 is 210. 210 is well over 180 degrees, meaning there's not enough room for a third angle, and you can't have a triangle with only two angles. Therefore, this 160 is not a plausible answer, so the only answer we have is 19.9 degrees for our possible angle measure of angle C. So again, once you find your answer for an angle, you're going to check for more by subtracting from 180. If the angle that is given and the possible answer is well less than 180 and gives you room for a third angle, then you're fine. If it does not, then you cross it out and you only have the angle that you started out with. Let's try two more examples and then we'll call it good for law of sines. Again, this one they didn't provide you an image, so that's fine. We're just going to draw an image. How do we draw it? Doesn't matter. We know that there's no right angle because it doesn't tell us that we have an angle. So this is going to be C, this is going to be A, this is going to be B, doesn't matter. Angle measure of angle A is 114. AB is 34, BC is 12. We want to find the angle measure of C. So let's call this one theta this time. Again, start with what you have, work with what you know. So I have an angle and a side. So sine of 114 over 12. I have an angle. This is what we want. So we want sine of theta. And I have my side, which is 34. Step number one is always to get sine of theta by itself. So I'm going to multiply 34 to both sides. So I have 34 times sine of 114 degrees over 12. And that's equal to sine of theta. We need to check if this is in between 1 and -1. So this needs to be between 1 and -1. So let's check. 34 times sine of 114. I'm going to divide that by 12. And that gives me 2.588 equal to sine of theta. Because this is outside of the range, you stop working. It's not between 1 and -1. Therefore, the answer is no solution. It's not possible. It's like imagine saying that you can have 3 apples to eat, but then you're telling someone you ate 5 apples. It's not possible. You only had 3 apples. How can you eat 5 apples? It doesn't make sense. Same thing with here. If it's outside of the range, it doesn't make sense. No solution. Try example number 3. Again, no picture, so we're going to draw a picture ourselves. So your C, A, B. Angle B is 47 degrees. AB is 33. AC is 26. We want to find the angle measure of angle A. In this case, I'm going to call it theta as well. Start out with what you have. Let's see, what do we have? I have an angle. I have a side, so sine of 47 degrees over 26. And I have an angle. Oh, this one might be a little bit more challenging because I'm thinking angle side, angle side. Did I miss something? Let's double check here. Oh, so I think what's going to happen, you guys, is we're going to have to do this like twice, because if I use this theta here and I go across the street, I don't know this. I don't know this. So I have two unknowns. It's like saying, what is sine of theta when I don't know what the side measure is? So I think what's going to happen is we're going to have to kind of play around with it. I do know the side length of AB. However, I do not know the angle measure for angle measure C. This is unknown. So I'm going to call it X. So what I can do is I can solve for X, get that angle measure, and then use it to solve for my angle of theta. So again, this one here, too many unknowns, we don't need it. So I'm going to say sine of 47 degrees is equal, just kidding, is divided by 26. That is equal to sine of X over 33. I'm going to multiply to 33 both sides. So I have 33 times sine of 47 over 26. Again, you got to make sure that that is within your range. So let's check it out. 33 times sine of 47 divided by 26. That gives me 0.928-ish, which is between it is between -1 and 1. So then I'm going to do the inverse. So the inverse of sine of 0.928-ish. Again, I'm going to use a more precise number in my calculator. And that's going to be equal to my angle measure of angle C. So using the inverse second of sine, inverse of sine, 0.92825662126, again using the more precise answer, and that gives me a value of 68.16. Now that we have our X value, we got to go back to our triangle and see kind of what makes sense. Now this X value, again, is not the only value. It is a positive angle, so we have to check if potentially we could have another angle that this angle X could be. So what we're going to do is we're going to take 180, subtract 68.16 from it to see what our potential possible angle could be. So 180 minus 68.16, and that gives me 111.84. So this could be our angle, and this could be our angle for angle X, or in this case, angle C. So we had our A, B, C, so this is what we were solving for. However, that's not what we need. That's not what the question is asking us. The question is asking us for angle A, or what we called it as angle theta. So in order to kind of figure out what we have is we're going to take these two possible angles and see what angle theta could be. So we know that the measure of angle B is 47 degrees. Then we need to know what the measure of angle C is. So we have two options. So that means for measure of angle A is going to have two options as well. So option number one is we have 180 degrees for three angles, and that's going to equal to the angle of measure theta, right? Plus, let's do 68.16 first, plus 47 degrees. So if I do that, then theta will then equal to, let's do some quick math here with our calculator. That means theta could potentially equal to 64.84 degrees. Now, that could happen, or we could have another potential angle, because I drew this randomly. This could not be like the actual triangle we have. We have more than one option for this triangle to look a certain way. So now we have 180 equal to theta. However, instead of 68.16, we're going to use 111.84 plus 47. And why can I use the 111.84? Because it's smaller than 180 degrees, and when I add it to 64, it's still smaller than 180 degrees. So that means it leaves room for this third angle. If it doesn't leave room for that third angle, that means it's not a possible angle measure. Oops, instead of subtracting, I added. So let's subtract 111.84, subtract 47, and that gives me that theta could potentially, and I still did it wrong, so let's try this again. Keep typing in the wrong thing. 180 minus 111. Last time I just typed in 11, so it gave me a weird answer. And I just added, subtract. 21.16. So for angle A, we have two potential angle measures. We either have 64 degrees or we have 21 degrees. All right, beautiful people, that is it for law of, what did we do? Law of sines. That is it for law of sines. Enjoy the rest of your day. And in our next video, we will be discussing law of cosines. Bye.